Exploration of properties of concrete by partial replacement of fine aggregate with clastic sediment stone powder. Abstract concrete is widely used composite material in civil engineering world. The components of concrete are cement, fine aggregate, coarse aggregate, and water. River sand is most commonly used as fine aggregate. The river deposits are the most common source of fine aggregate. Nowadays the natural river sand has become scarce and very costly due to greater demand than its supply. Going for an alternative or supplementary material which can be used as partial or full replacement of conventional material can play an important role in conservation of natural resources. Clastic sediment stone powder disposal became a worldwide problem. This study has been carried out at 0%, 15%, 30%, 45%, and 60% replacement of natural river sand. From experimental results it is observed that workability of concrete decreases with increase in clastic stone powder content. This decrement in workability may be attributed to finer size of clastic sediment stone powder particles than those of river sand particles. Keywords: clastic sediment stone powder. Introduction. Concrete is widely used composite material in construction world. Some alternative materials have already been used as a fine aggregate in concrete, e.g. fly ash, steel slag, glass powder, marble powder, etc. Clastic sediment stone powder is considered a waste product obtained by breaking down larger size stones into smaller sizes for making coarse aggregate. In India, clastic stone powder is produced in large quantity and therefore their consumption becomes necessary in order to reduce environmental problems. By utilizing clastic stone powder as replacement of sand would reduce the environmental problems and also results in economical concrete construction. Keywords: workability, compressive strength, tensile strength, flexural strength. 2 Literature review. V. L. Bonavetti et al., 1994, studied the effect of stone dust on different properties of mortar. It was observed that the water required for maintaining a constant flow increases with increase in stone dust content in mortar. The air content of fresh mortar decreases until 10% of sand replacement by stone dust. Beyond that it increases to the same level as that of control mortar. The replacement was made in steps of 5%, 10%, 15%, and 20%. At the curing age of 7 days, the compressive strength increased by about 44%, 72% than control mortar. However, at higher curing ages the compressive strength was same as that of control mortar. The flexural strength was improved at all ages of curing. The drying shrinkage was increased with increase in stone dust content and attributed this increment to increased water content of mortars containing stone dust. Sudarshan and Raman et al., 2005, assessed the compressive strength of concrete by replacing sand with quarry dust partially along with some admixtures viz. Silica fume and Class F fly ash. It was observed that partial incorporation of quarry dust resulted in reduction of compressive strength and was more evident when quarry dust content increased. It was observed that compressive strength reduction was compensated by incorporation of silica fume and fly ash. Omar et al., 2012, investigated the influence of limestone waste as partial replacement for sand in concrete. The replacement was made in steps of 25%, 50%, and 75%. The compressive strength was checked at the curing ages of 7, 28, and 90 days. Marble powder was used as an additive in steps of 5%, 10%, and 15% by weight of cement. The tests were done in 2 phases with varying cement content, 350 kg per cubic meter and 450 kg per cubic meter. It was found that, at 50% replacement increment in compressive strength was 12% than normal concrete at the curing age of 28 days. Increment in tensile strength and flexural strength were about 17% and 8% by using 50% limestone waste and 15% marble powder. Hussam Najm et al., 2016, investigated the various properties of concrete by replacing sand with granite powder and iron powder. The replacement was made in steps of 5%, 10%, 15%, and 20%. The compressive strength was best at 10% replacement of sand by granite powder, whereas splitting tensile strength and flexural strength were best at 15% and 10% respectively. Concrete containing iron powder has showed increment in compressive strength, splitting tensile strength and flexural strength with increase in iron powder content. However, this increment was more evident in flexural strength than those of compressive strength and flexural strength. Aditya Rani et al., 2016, determined the effect of different kinds of stone waste, limestone, granite stone, marble etc., on the properties of concrete and observed that these different kinds of stone wastes can be used in concrete partially, as their partial incorporation in concrete showed increment in strengths, greater resistance to acid attacks, very high resistance to chloride penetration and very low porosity as compared to the normal concrete. Prarthita Basu, 2016, studied the compressive strength characteristics of concrete by partially replacing ordinary Portland cement with fly ash along with out at 0%, 15%, 30%, 45%, and 60% replacement of natural river sand. 1. To compare the workability of M25 concrete by partial replacement of clastic sediment stone powder with fine aggregate in proportions of 0%, 15%, 30%, 45%. 2. To study the effect of clastic sediment stone powder on compressive strength, splitting tensile strength and flexural strength for M25 concrete I, batching by volume. 2. Batching by weight. Natural sand by crusher dust and waste marble powder in different proportions. It was found that 10% replacement of sand by crusher dust along with 20% replacement of ordinary Portland cement by fly ash gives satisfactory results. It was observed that the concrete containing fly ash, marble powder, and crusher dust was more economical than normal concrete. Rani et al., 2016, studied the effect of crushed brick by using partially as fine aggregate in concrete. The sand was replaced by crushed bricks in steps of 15%, 20%, and 25%. It was observed that by using 20% of crushed brick the compressive strength increases, whereas by using 25% of crushed brick the compressive strength decreases. The increment in compressive strength at the curing age of 7 days was found to be 17.62% than of normal concrete and was obtained at 20% replacement, whereas at 25% replacement the decrement in compressive strength was found to be 1.277% than that of normal concrete. The splitting tensile strength and flexural strength were found best at 20% replacement. Chandrasekhar Reddy et al., 2017, investigated the durability of concrete by replacing sand with quarry dust and cement with fly ash. The natural sand was replaced by quarry dust in steps of 0%, 10%, 20%, and 30% and cement by fly ash in steps of 0%, 10%, 20%, and 30%. The concrete containing fly ash was found to have low resistance to sulfuric acid solution over the control mix, and most percentage loss in weight was observed at 20% replacement of quarry dust and fly ash. The maximum percentage loss of compressive strength was found at 20% replacement of quarry dust and 30% fly ash. 3. Objective of the study. Clastic sediment stone powder disposal has become a worldwide problem. Moreover, over-exploitation of natural construction materials has led to their depletion. The acute shortage of natural river sand has stimulated construction industry to go for an alternative material which can be used as replacement of natural sand. This study has been carried. The following are the objectives of study. 4. Experimental program. Fine aggregate, natural river sand, was partially replaced by waste sandstone powder in the production of concrete in order to reduce the waste load and to obtain an alternative material of sand for production of concrete. Clastic stone powder, being a waste material when used as fine aggregate, leads to economical production of concrete, hence economical concrete construction, and simultaneously compensates the shortage of natural river sand. Design concrete mix M25 of ratio 1:1.79:2.37, IS, 10262 to 2009, was investigated adopting with C ratio of 0.45. For the production of concrete, material used were ordinary Portland cement 43 grade, natural river sand as fine aggregate, coarse aggregate, sandstone powder as replacement of natural river sand and potable water. The maximum size of crushed aggregate was 20 mm. Batching of materials. The measurement of materials for making concrete is known as batching. Normally batching is done by two ways. Volume batching is not ideal method of batching. Weight batching, this is the recommended method of batching. Batching by weight is preferred over batching by volume. Tests conducted on fresh concrete. Fresh concrete is defined as that concrete which can be molded to any shape. The slump test is used for fresh concrete. Workability. The workability of fresh concrete was determined by slump cone test. The test was done as per IS 1199:1959. Fig. Determination of slump value of concrete. Apparatus required. One mold in the form of a frustum of a cone having height 300 mm, bottom diameter 200 mm and top diameter 100 mm. 2 tamping rod having diameter 16 mm and 60 mm long. 3 non-porous base plate. 4 measuring scale. I compression test. 2 splitting tensile test. 3 flexural test. Test procedure. The internal surface of mold was cleaned. The mold was placed on non-porous base plate. The slump cone was with fresh concrete in 4 layers. Each layer was given 25 strokes by tamping rod. After filling the cone up to brim, the excess concrete was struck off by trowel. The cone was lifted gradually and horizontally and measurement was taken. Same procedure was done for all replacement levels. Tests conducted on hardened concrete. Compression test, IS 516-1959. Compressive strength test has been done as per IS 516-1959. For determination of compressive strength, concrete cubes having size 150 mm x 150 mm x 150 mm were cast, demolded after 24 hours and cured for their respective test days. 6 cubes were cast for each replacement level. The compressive strength has been checked at the age of 7 days and 28 days. The compression test has been done by compression testing machine, CTM. The total numbers of cubes cast were 60. Test procedure. Cubes were taken out from curing tank, excess water was wiped off and left for dry. The bearing surface of compression machine was cleaned. The cubes have been placed in machine in such a manner that the load shall be applied to the opposite sides of cubes. The cubes were placed centrally on base plate and their top surface was touched with the movable part of the CTM. Load has been applied gradually and constantly at the rate of 140 kg per square centimeter. /min without any shock. The failure load was noted and the compressive strength was determined by formula given below. Compressive strength, MPa, equals failure load / cross-sectional area. Splitting tensile strength test, IS 516-1959. For investigation of splitting tensile strength, concrete cylinders having size 150 mm x 300 mm, diameter x height, were cast, demolded after 24 hours and cured for 7 and 28 days. The splitting tensile strength has been checked at the age of 7 and 28 days. 3 cylindrical specimens were cast for each replacement. The splitting tensile strength test has been done by compression testing machine, CTM. Splitting tensile strength is calculated by formula, foot equals 2p/pdl. P equals failure load, D equals diameter of cylinder, L equals length of cylinder. Flexural strength test, IS 516-1959. For determination of flexural strength, concrete beams having size 700 mm x 150 mm x 150 mm were cast, demolded after 24 hours and cured for 7 and 28 days. The flexural strength was checked at the age of 7 and 28 days. 3 beam specimens were cast for each replacement. Total numbers of 30 beam specimens were cast. The flexural test has been done by Universal Testing Machine. According to IS code 516-1959, the specimen is tested under 2-point loadings over an effective span of 600 mm divided into 3 equal parts and restrained. The load shall be applied at the rate of 400 kg per minute for the 15.0 cm specimen and at a rate of 180 kg per minute for the 10 cm specimen. Flexural strength is given by flexural strength, MPa, equals PL/BD2. P equals failure load, L equals center to center distance between the support, 600 mm, B equals width of specimen, D equals depth. V results and discussion. The results of various experimental investigations carried out on raw materials, fresh concrete and hardened concrete and their graphical representation are presented in this chapter. The effect on the properties of concrete are also presented in this chapter. Properties of cement. In this study ordinary Portland cement, OPC, 43 grade conforming IS 8112, 1989 was used. The specific gravity of OPC is generally taken as 3.15. The fineness of cement was 2.59. Properties of fine aggregate. The aggregate fractions ranging from 4.75 mm to 150 are termed as fine aggregates. The specific gravity of fine aggregate is 2.62, fineness of fine aggregate is 2.68 and water absorption is 1.21%. Properties of coarse aggregate. The aggregate fractions ranging from 80 mm to 4.75 mm are termed as fine aggregates. The specific gravity of fine aggregate is 2.65, fineness of fine aggregate is 6.90 and water absorption is 0.81%. Properties of clastic sediment stone powder. Clastic stone powder is a fine material formed during the process of comminution of large-size stones into coarse aggregate or crushed sand. The specific gravity of fine aggregate is 2.51, fineness of fine aggregate is 2.68 and water absorption is 1.83%. Workability. Workability of fresh concrete was determined by using slump cone and the results obtained are presented in table. From experimental results it is evident that workability of concrete decreases as the percentage of stone powder increases. Compressive strength test has been done as per IS 516-1959. For determination of compressive strength, concrete cubes having size 150 mm x 150 mm x 150 mm were cast, demolded after 24 hours and cured for their respective test days. 6 cubes were cast for each replacement level. The compressive strength has been checked at the age of 7 days and 28 days. Future scope. 1. Examine the acid resistance, porosity, and durability of concrete by replacing fine aggregate with clastic stone powder fully. 2. Determine the mechanical properties of concrete construction units like hollow concrete blocks etc. by using clastic stone powder as fine aggregate. 3. Assess the effect of clastic stone powder on the mechanical properties of concrete at higher grades like M30, M35, and M40.